Alrighty, in this video, we are going to be looking at antiderivatives, aka the start of Unit 4, aka integration. So thinking back about in Unit 2 and Unit 3, we talked a lot about derivatives. And this time, let's say that I give you the derivative and I want to find the original function. So that's going to be our goal for this unit, is to find the original function. So looking at number 1, number 2, number 3, and number 4, let's say that I give you the derivative and your goal is to find the original function. So think about some strategies that you use in terms of 1, 2, 3, and 4. Pause the video and then play it once you are ready to find out what the original functions are. All right, so whenever we took a derivative, we always looked at the exponent and we always multiply it to my coefficient and then subtract the power. So what we're going to do if I have the derivative is just do the opposite role. So I'm going to reverse it now. So instead of multiplying the exponent's coefficient and then subtracting 1, I'm going to add the coefficient, not add the coefficient, add the exponent by 1. In this case, that's going to be 2. And then instead of multiplying, I'm going to be dividing by whatever my exponent is. This is going to give me x squared. I'm going to check my work. The derivative of x squared is 2x. Likewise, for number 2, I'm going to add 1 to my exponent. That's a 4. And then I'm going to divide that by my coefficient instead of multiplying. That's going to give me 2. And if I take the derivative of 2x to the 4th, I'm going to get 8x to the 3rd. Number 3 should be a derivative that you should have memorized. The derivative of negative cosine is sine. Likewise, for number 4, this one should be another derivative that you have memorized. That's going to be the square root of x. Now, I'm going to give you a hint that for number 1, 2, 3, and 4, these aren't my only functions that's going to give me a derivative of 2x or 8x to the 3rd or sine of x or 1 over 2 root x. Because what I'm going to do here is probably plop a pi or an e or a 3 or a 2 here. And if I still plop a constant, remember that the derivative of a constant is going to be 0, which still gives us our derivative of 2x, 8x to the 3rd, sine of x, or 1 over 2 root x. So if I could plop any constant, then what I'm going to do is add a plus c to the end of each of my original functions. And that plus c is going to be a placeholder for my constant of integration. So it's a constant of integration. Now later on the line, we are going to be finding out what the c value is based off of certain conditions and certain constraints, but we are not there yet. All right, that being said, if I have big function f of x, it's an antiderivative of a function f of x if big F prime of x is equal to f of x for all x to the domain of f. The process of finding an antiderivative is called antidifferentiation. The family of all antiderivatives of a function f of x is the indefinite integral and of f with respect to x, and is denoted by the integral of f of x dx. This is read as the antiderivative of f with respect to x. So we have a couple of things going on here. So we have the variable of integration. That's going to be dx. Variable of integration. We have f of x. F of x is going to be called the integrand, small f of x. That's what we are taking the antiderivative of. And then f of x is my big F of x is my antiderivative. All right. So looking at number 1 and number 2, we just did the opposite of the power rule, right? So that's what we're going to do here for these couple examples, where we are just going to do the opposite of power and see what happens. So the power rule for antiderivatives is what we call it. So the power rule for antiderivatives is us going to add 1 to our exponent and then divide by whatever my exponent is. So in this case, I'm going to add 1 to x to the 3. That's going to be x to the 4th. And then I'm going to divide that by 4 to get x to the 4th divided by 4. Because if I take the derivative of this, I should get x to the 3rd. Likewise with the 2, I'm going to have 2x. The derivative of 2x is 2, so that checks out. And then don't forget, because this is an indefinite integral, we are going to have a plus c as our answer. So we have big F of x is equal to this lovely thing right here. And don't forget about the plus c. If you don't include a plus c, the whole question's wrong. So make sure that on your quiz, you have plus c if you are given an indefinite integral. All right, so looking at number 6 here, we are going to up my power. That's going to be 5 over 2. And then we are going to divide that by our coefficient. In this case, I'm just going to take the reciprocal of that. That's just going to be 2/5. Check your work. So if I were to use power rule for derivatives, the 2/5 and the 5/2 will cancel out to be 1. And then I'm left with a 3/2 here. So that checks out. Likewise, with the 4x, I'm going to up my power, and then I'm going to divide, take the derivative of that. So the derivative of 2x squared is 4x. That checks out. The antiderivative of 1 is just x. And then you also need a plus c at the end. All right, so let's look at let's say number 10 here. Number 10, we have 3 plus secant x tan of x dx. So if I were to look at this, I'm going to take the antiderivative of 3, that's just 3x. And then thinking about the antiderivative of secant x tangent of x, we need to think which trig function that is. That's going to be secant, because remember that the derivative of secant is secant x tangent x. And then, of course, don't forget to plot a plus c at the end. Likewise, for number 12, I want to find the integral of tangent square of x plus 1. The problem is, I don't know what the integral of tangent square of x is, right? But I do know that tangent square of x plus 1 is an identity. This is the same thing as saying secant square of x. And guess what? We know what the antiderivative of secant square of x is. That is going to be tangent of x, because remember, the derivative of tangent of x is secant square of x. And don't forget your plus c. All right. We have a special rule for 1 over x right here. The derivative of something like this is going to be ln of x, but your x is going to be absolute value. So the derivative of 1 over x is ln absolute value of x. Now the antiderivative of this, I am going to go ahead and rewrite this as negative 2x to the negative 3. I'm going to up my power. Oops, not negative 3, negative 2, sorry. I'm going to up my power. That's going to be negative 1. And then I'm going to divide that by my coefficient of negative 2, which gives me a positive 2. So this tells me that the antiderivative of this lovely thing right here is 2x to the negative 1. Now, to make sure that this is correct, I'm going to take the derivative of this. So I'm going to multiply this. That's going to give me a negative 2. And I'm going to subtract this, which is going to give me a negative 2. So that's going to give me negative 2x to the negative 2, which is what we want. And of course, we have a plus c. All right, so something like number 15 here, where we have 3x minus 1 square. I don't know, or I don't have any ways to integrate this right now or special methods. We'll look at u substitution in a couple of days, but right now we don't know what u sub is. So what we're going to do, unfortunately, is expand this out and then take the antiderivative of each term by using the power rule for antiderivatives. If I were to use the power rule for antiderivatives, I'm going to get, let's say, 3x to the third minus, we have x squared, so that's 3x squared plus x. And then, of course, don't forget about your plus c. All right, let's look at number 14, and then we'll look at 16. For number 14, we have 5e to the t. Now remember that the derivative of e to the t is e to the t. So the antiderivative of e to the t is going to be, guess what? E to the t. Now, once again, I don't know what the antiderivative of 1 over cosine square of t is. So what we're going to have to do is, once again, think about what that kind of looks like in terms of what we know. We know that 1 over cosine square of t is going to be the same thing as secant square of t. And we know that the antiderivative of secant square of t is tangent of t plus c. Same thing with number 16 here. I don't have a way to figure out the opposite of quotient rule. So what we're going to do is go ahead and divide out the x to the fifth to each of the terms in the numerator. That's going to give me x to the negative 3, 4x to the negative 4, 5x to the negative 5. And then we're just going to take the antiderivative of this by upping my power and then dividing by whatever my exponent is. Upping my power and then divide by my exponent. Upping my power, then dividing by my exponent, and then of course a plus c. I'm gonna write this, rewrite this so that it's prettier. But obviously the top expression is, technically correct still, but, we gotta make it pretty. All right, so let's say that I have something like number 18 here where I have the derivative and I also have an initial condition. So what I'm going to do is actually find out what the constant of integration is based off of my initial condition, which is really fun. So looking at number 18 here, what I'm going to do is take the antiderivative of 2x minus 1, which is going to be x squared minus x plus c. And what we're going to do is plug in our value of f of 2 is equal to 5. So I have 5 is equal to 2 squared minus 2 plus c. And what we're going to do is just solve for c. 5 is equal to 4 minus 2 plus c. 2 plus c. C is equal to 3. And then if I were to bring everything together, I'm going to have x squared minus x plus 3. Because if I were to take the derivative of this, I'm going to get 2x minus 1. And of course, the derivative of 3 is going to be 0. Likewise, for number 20, I'm going to do the same thing here, where I want to take the antiderivative of x to the 1/2. So I'm going to up my power. And then I'm going to divide, so that's going to give me 2/3. 2/3 x to the 3/2 plus c. Now I have an initial condition of f of 9 being equal to 6. So I'm going to plug in everything I know. I'm going to say 6 is equal to 2/3 9 to the 3/2 plus c. 9 to the 3/2, the square root of 9 is 3. 3 cubed is 27. So I have 2/3, 27 plus c. If I do 2/3 times 27, I'm going to get 18. So 6 is equal to 18 plus c, which means that c is equal to -12. And if I were to put everything together, I know that my function for number 20, let me put this in a different color, is going to be 2/3 x to the 3/2 minus 12. This right here is my final answer. Once again, if you have time, check your work. So if I were to multiply this out, that's going to give me 1. And then if I were to subtract my power, I'm going to get 1/2. So x to the 1/2. The derivative of -12 is 0. So x to the 1/2, square root of x, it checks out. All right, so same thing with number 19 and number 21, but I'm not going to do that. In the next video, we are going to be talking about Riemann sums and all of that good stuff.